Hello, welcome. In this class, we solve some numerical problem based on moment of inertia. This is the first question from moment of inertia. To find the moment of inertia of the angle section as shown in figure about axis passing through CG. Figure is given. Find the moment of inertia of this figure about axis which is passing through CG. Now find a CG where the CG is center of gravity is pass of this section. First calculate the CG of this section. Y bar is equals to A1 Y1 plus A2 Y2 divided by A1 plus A2. Using this formula we find out the CG of this section. Let me divide it in two part of this section. This is section 1 and this is section 2. Find the area of this section. A1 equals to 8 into 2 equals to 16 centimeter square, and area of the section 2 is equals to 16 into 2, length into breadth is equals to 32 centimeter square. Find the CG of each section. Let me consider we will find out the CG from base. Let me consider the base. This is the base of x-axis and this is the y-axis. Let me consider this is distance of section 1 is CG distance y1, which is equals to 14 plus 2y2 equals to 15, and this section and CG of this section will be from the base, from the bottom will be y2 equals to 16 divided by 2 equals to 8. Here I am writing y1 equals to 15 and y2 equals to 8 centimeter. Now calculate the CG. Y bar is equals to A1 equals to 16 into Y1 equals to 15 plus A2 equals to 32 into Y2 equals to 8 divided by A1 is 16 plus A2 is 32. This is equals to 10.33 centimeter from the base. So CG of whole section is 10.33 centimeter. So I am consider here is the 10.33 centimeter of the CG from the base. I am using the black pen to highlight it. Of CG of y bar of the whole section is y bar equals to 10.33 centimeter. Now find out the moment of inertia of each section. This is a section 1 and this is a section 2. Find out the CG of section 1 about, find the moment of inertia of the section 1 about CG. I equals to, this is the rectangle part, I C G say 1, part 1 is equals to, part 1 equals to, this is the 8 is the B, 8 into D is the 2, 2Q divided by 12. This is equals to plus about CG we will find out the moment of about the CG we will find out the moment of inertia of section 1. ICG1 is equals to 8 into 2Q divided by 12 by using parallel axis theorem. What is the parallel axis theorem? Parallel axis theorem is the IAB equals to IG plus A into H square. Let me consider what, let me find out the H. H will be, this is the CG of the whole section, this is the CG of whole section, CG of the whole section. Find a CG distance from section 1 to CG of the whole section is equals to H1. H1 equals to what? H1 equals to, let me write down here, H1 equals to, H1 equals to, H1 equals to what? You can also find out the H1. This is from here to here is the 15, means y1. If I subtract y bar from y1, so we can get the h1 y bar. Here the y1 is equals to 15, from here to here 15 minus y bar equals to 10.33, which is CG of the whole section. From the base subtract the y bar is equals to 10.33 is equals to 15 minus 10.33, 15 minus 10.33 is equals to 4.67, 4.67 centimeter. So H1 equals to 4.67 centimeter. So ICG1 equals to will be, by using parallel axis theorem, about center of each section of the moment of inertia plus area of the section into h square, perpendicular CG distance square. I equals to, we know, B dq divided by 12 plus A into h1 square, A1 into h1 square. So B for this section, B equals to 8, here to here, this is total distance of 10 centimeter, total distance is 10 centimeter. So here to here is 8 into depth of this section is 2 cube divided by 12 plus A equals to, A1 equals to, we find out, we already find it, 16 into H equals to 4 point, H1 equals to 4.67 square. So this is equals to, let me calculate it, 8 into 2 cube divided by 12, 8 into 2 cube divided by 12 plus 16 into 4.67 square. This is equals to 354.27 centimeter to the power 4. Unit of the moment of inertia is centimeter to the power 4. Now calculate this is ICG1. Now calculate the moment of inertia of section 2 This is ICG2 is equals to, for this section, B equals to 2 centimeter, 2 into D equals to 16 centimeter, 16 cube divided by 12 plus area of this section is 32 into area of this, using this formula, area of the section 2 is 32 into H2. Now find out the H2. H2 will be of the CG of this section, of only this section is, center of this section is 8, and CG for this section to whole CG of this section is equals to H2. Now find out the H2. H2 I am find out here. I am find out the H2. H2 equals to total distance y bar from base to CG of the whole section, y bar minus CG of only this section is y2. This is equals to y bar equals to, we already find out 10.33 minus y2 equals to 8 the whole square, 8 whole square. Now calculate it. 2 into 16 cube, 2 into 16 cube divided by 12 plus 32 into 10.33 minus 8, 10.33 minus 8 square, it is 856.39 centimeter to the power 4. So the CG of whole section of a whole angle section, CG of the whole angle section about axis passing through CG, about the moment of inertia of whole moment of inertia of the angle section about axis passing through CG will be ICG1 plus ICG2 is equals to ICG1. We have find it 354.27 plus, and ICG2 is 856.39. add it plus 354.27. This is equals to 1210.67 centimeter to the power 4. It is a very simple problem. We have find it the moment of inertia of the angle section. Now go to the next problem. A simple problem of I section. A girder of I section shape cross section has equal flange 12 centimeter by 2 centimeter connected by a web size is 20 centimeter by 2 centimeter. Determine the moment of inertia about is centroidal axis which is passing through the flange, which is parallel to the flange. Moment of inertia, find out the moment of inertia about centroidal axis which is parallel to the flange. Let me draw the I section. I section having equal flange of each size is given 12 centimeter by 12 centimeter by 2 centimeter. Let me draw the I section. Equal flange of I section. This is the flange, top flange. This is the wave size is given. Wave size is also given. Bottom flange and top flange are same size. Top flange of size 12 centimeter by 2 centimeter. This is the 12 centimeter and thickness of the flange is 2 centimeter. Here also bottom flange with also 12 centimeter and thickness of the flange is 2 centimeter and wave size is 20 centimeter by 2 centimeter. Thickness of the wave is 2 centimeter is given and depth of the wave is 20 centimeter. Sorry, this is 2 centimeter. This is 2 centimeter. Thickness of the wave is 2 centimeter and depth of the wave is 20 centimeter. Now calculate the moment of inertia about CG. This is a symmetrical section, so we can easily say the centroid will be center of the section. This is the CG line. This is the CG line passing through the centroid, passing to the center of the whole section. The total height of the whole section is 20 plus 2 plus 2 equals to 24 centimeter. So and total width of the flange is of the section is 12 centimeter. Now we can consider it the whole rectangle. This is the whole rectangle of size 24 by 12. Consider the whole rectangle of size B equals to 24 centimeter and depth of the rectangle is width of the rectangle is whole rectangle is 12 centimeter. B equals to 12 centimeter and depth of the whole rectangle is 24 centimeter. D equals to 24 centimeter. Now we can find out the moment of inertia of whole rectangle section. Let me find out the whole moment of inertia of a whole rectangle section. I passing through CG, I CG equals to B D Q divided by 12. This is equals to 12 into 24 cube divided by 12. This is equals to 12 cancelled and 24 cube is the answer. This is 13824 centimeter to the power 4. Now find out the moment of inertia of the, if I subtract of this void section of this void part, this is the void portion of the rectangle section. If I subtract this void portion and this void portion, then we will get the moment of inertia of the whole I section of solid I section about CG. Subtract this portion and this portion, find out the this moment of inertia of this portion and find out the moment of inertia of this portion and subtract from the whole rectangle section. Now what is this distance size will be, say this is small b, small b, small b equals to small b equals to, this is a 2 centimeter, thickness of 2 centimeter, center to center is 6, center to center is 6, then b equals to 6 minus 1 equals to 5 centimeter, and depth is given, this is d equals to 20 centimeter. Here also 2 cent, here also 5 centimeter and 2 centimeter. Then moment of inertia of this void portion is equals to I CG of void portion. Void portion is equals to B dq divided by 12. 2 into B dq by 12, because here is the void portion and here is the void portion. If I add both, then it will be 2 into B into dq divided by 12. Put the value, 2 into B equals to 5 into D equals to 20 cube divided by 12. Now calculate it, 2 into 5 into 20 cube divided by 12. This is equals to 666 and 6.67 centimeter to the power 4. So the moment of inertia of I section will be, moment of inertia of this I section will be about centroid, moment of inertia about centroidal axis, which is parallel to the flange. This is the flange and this is the parallel to the flange is CG. CG will be, this is the whole section, and is a void portion. So 13824 minus 666 6.67, this is equals to 13824 minus 666 6.67, this is equals to 7157.33 centimeter to the power 4. This is a very simple problem to find out. We can calculate also in different way. We also consider the different portion. This is portion 1, this is portion 2, and this is portion 3, and 3 different section we consider. We also can consider it, but it can be easily solved by this method, and you can also calculate by using parallel axis theorem. It is very simple. Now go to the next problem for different section. Let me try another section to find out the moment of inertia of T section. This is the last problem of this chapter and I close it after complete this problem of section. Let me consider a simple problem of I section to find the moment of inertia of inertia. Find the moment of inertia of a T section of the T section as shown in figure. Figure is given. Let me draw the figure of T section. The flange of the T section is this and the wave is this. Size of the flange is 12 centimeter by 2 centimeter and wave is depth of the wave is say 14 centimeter and thickness of the wave is also 2 centimeter. So find out the moment of inertia about CG. Moment of inertia about CG. First we have to find out the centroid of the section. Y bar is equals to A1 Y1 plus A2 Y2 divided by A1 plus A2. Let me consider this is the portion, this is the section 1 and this is the section 2, the flange section 1 and the wave section is 2. The area of the flange section A1 will be 12 into 2 is equals to 24 and area of the wave section is equals to 14 into 2 equals to 28 centimeter square. This is centimeter square. Let me consider the centroid from the base of each section will be, this is the base of the T section and this is the centroid of flange section from the base is equals to y1 which is equals to 12 plus 2 by 2 equals to 13 and centroid of the wave section from the base will be y2 equals to 14 divided by 2 is equals to 7. So here y1 equals to, have find out 12 plus 2 by 2 equals to 13 centimeter and y2 equals to 14 divided by 2 equals to 7 centimeter. Now we have to calculate the CG of whole section is y bar equals to A1 equals to 24 into y1 equals to 13 plus A2 equals to 28 and y2 equals to, this is y2 equals to 7. divided by A1 plus A2. A1 is 24 plus A2 is 28. Calculate it by calculator. 24 into 13 plus 28 into 7. 28 into 7 is equals to 508 divided by 24 plus 28. 24 plus 28 is equals to 9.769, say 9.77. This is 9.769 centimeter. Also we can write it 9.77 centimeter from base. So this is the centroid, center of gravity, CG distance from or neutral axis, centroid axis or neutral axis from CG, from base is y bar is equals to 9.77 centimeter. Now calculate the moment of inertia. Calculate the moment of inertia. I is equals to, I am directly calculate it. CG is equals to I CG1 plus I CG2 is equals to B1 D1 Q divided by 12 plus A1 into H1 square plus B2 into D2 Q divided by 12 plus A2 into H2 square. Now here we don't know the H1 and H2. Let me find out the H1 and H2. Here I am find out the H1 and H2. H1 for section 1 is equals to, from here to here, this distance is H1 and this distance is H2. H1 will be y1 minus y bar is equals to y1 equals to 13 minus y bar equals to 9.77 is equals to 13 minus 9.77 is equals to 3.23 centimeter, and H2 is equals to from CG2 of section, CG of whole section, from CG of whole section to CG of wave section is H2. This is equals to y bar minus y2. y2 is this distance, CG distance of wave section. Y bar equals to 9.77 minus y2 equals to 7 is equals to 2.77 centimeter. Now put all the value in this equation. B1 equals to 12 into D equals to 2 d1 equals to 2 cube divided by 12 plus area of the section 1 is 24 into h1 for section 1 is equals to 3.23 square plus b2 equals to 2 2 b2 equals to 2 and d2 equals to 14 cube divided by 12 plus area of the section 2 is equals to 28 into h2 is equals to 2.77 square 2.77 square. Twelve into 2 cube divided by 12 means 8 plus 24 into 3.23 square. This is equals to 258.39. This is equals to 258.39 plus, calculate this portion, 2 into 14 cube divided by 12 plus 28 into 2.77 square. This is equals to 672.17. 672.17. This is equals to plus 258.39 is equals to 930.56 centimeter to the power 4. This